Next is diffraction at a single slit. So we are going to consider a single slit. So using this single slit, how the diffraction is produced. Let us consider a parallel beam of light which falls normally on a single slit AB, and this has a width A. So this is a AB and this has a width A, and here parallel beam of light from any source is made to fall. Okay, then the diffracted beam falls on the screen which is kept at a distance. So from here the diffracted beam falls on the screen. Yes, and the center of the slit is C. So this is a slit, is not, and this is A and this is B. This center we are considering as C. A straight line through C perpendicular to the plane of the slit. So straight line which is through C and which is perpendicular to the slit, what happens? It meets the point. Okay, it meets the center of the screen at O. So center of the screen, it meets at a point O. Okay, this meets at the point O. We would like to find the intensity at the point P on the screen. So at any point on the screen, we would like to find the intensity. So the lines joining the P to the different points on the slit can be treated as a parallel lines. So from the slit, so this is a slit. Okay, so from the slit, so what are all the different lines which have been joining this? Okay, and that angle if we measure, okay, and that is being normal to CO. Okay, then here is a diagram. So this is a slit and this slit has a width A and this is represented as AB and parallel beam which is coming over here and C to be the center. So from the center it moves to the center of the this ray which is passing through the P and it passes to the center which is O. Okay, and these are all the diffracted beams and it makes the angle theta, and here we are placing with the two lenses L1 and L2. Okay, clear? So next is all the waves start parallel to each other from different points, interfere at the point 1, okay, that is at the point P. So all the waves if you see they are seem to be parallel, so they does not meet, okay, but they finally meet at the point what? P. Okay, this point P is in the geometrically shadowed region. So this point P is in the geometrically shadowed region with the central maxima is spread. Okay, and we have to find with the condition of the point to be various minima. Clear? So the basic idea is to divide the slits into such smaller even this number of parts. Okay, so we are going to split this slit into many number of parts, then add their contributions at P. So whatever rays are coming to the point P, that point is being added. Okay, the proper path difference to show the destructive interference that takes place at the to make it to be minimum. Okay, so with proper interference, destructive interference, it meets at the point P. Clear? Condition for P to be the first minimum. So first condition is if you are considering the P to have the first minimum, then let us divide the slit AB into two halves. So AB is first going to be split into two halves. One is AC. AC is one part and the remaining part is CB. Now the width of AC is what? A by 2, because this full distance is A, is it not? And so if you want this half distance, this is A by 2 and this is again A by 2 and the corresponding points. The path difference of light waves from different points which is meeting at P and interfere to make the first minimum. So from the light source it meets at the point P, and to have the first minimum, the path difference del to corresponding points, we can write it as del which is equal to the side is what? A by 2 into sine theta. Okay, so this is a formula for del which we are taking. Del is equal to A by 2 into sine theta. Okay, so next we have the condition for the P to have the first minimum. So first minimum, the condition is what? The del is equal to lambda divided by 2. Okay, so what is the condition for first minimum is del, which is equal to lambda divided by 2. So lambda divided by 2, if you are substituting here, divided by 2 get cancelled, so we get a sine theta is equal to lambda. This is a first minimum. Clear? So next is, if you are going to have the second minimum. Yes, condition for P to have the second minimum. Before that, we have this slit, which is fully AB, and this is being split into half. So this condition is what? A by 2 into sine theta. Okay, and next is second minimum. So for finding out the second minimum, width of each part, because it is considered to be of 4 equal parts. Okay, so A, B is considered to have the 4 equal parts. So each part will have what? A divided by 4. Okay, so each part will have the width A divided by 4. And so the difference is what? Del is equal to A by 4 into sine theta. Before this we had a by 2 into sine theta, and so here we are having a by 4 into sine theta. But what is the condition for minimum? That is same, which is lambda by 2. Okay, so instead of del, if you substitute as lambda by 2, we get a by 4 sine theta, which is equal to lambda divided by 2. Yes, now on both the sides 2 get cancelled, and here we have the 2, and so 2 goes here, and so we get a sine theta, which is equal to 2 lambda. This is the condition for second minimum. Okay, so what is the condition for first minimum? It is a sine theta, which is equal to what? Lambda. Okay, here we have a sine theta, which is equal to 2 lambda. Same way, when you are finding for the third minimum, okay, so each one is split into what? 6 part. Okay, so the slit is going to be split into 6 equal parts, and so we have a by 6 sine theta, which is equal to lambda by 2. And here again we are cancelling this, and this 3 goes here, and so a sine theta is equal to what? 3 lambda. So this goes on, and if you are finding the value for nth minimum, okay, for first order it is just lambda, for second order 2 lambda, for third it is 3 lambda, and for nth medium it is n lambda. Okay, so that is the next one we are writing. So it is divided into 2n parts. Here we are writing for nth order, it is divided into 2n, and so it is divided by 2n into sine theta, which is equal to lambda divided by 2. Now 2 get cancelled, so we get a sine theta, which is equal to n lambda, and this is for nth minimum. Okay, so clear? So this is for all the minimum, first, second, third, as goes on till nth minimum. Clear? Same way, next is we are going to find for maximum. Okay, so for the points of the maximum, the slit is being divided into odd numbers. Before this we are finding for minimum, and so we divided into even numbers such as 2, 4, 6 and n, that is 2n, is not. Here it is going to be split into odd number of parts. Okay, for the first maximum to appear, we are splitting that into 3 parts. Okay, and so we are writing a by 3 is equal to lambda by 2. Okay, so 3 comes here, and so we get a sine theta, which is equal to 3 lambda by 2. Yes, same way, next is for second minimum. So it is second, you will be considering as 5 parts. Okay, and so we are writing a divided by 5, which is equal to lambda by 2. 5 goes here, and so a sine theta, which is equal to 5 lambda by 2. And next, for the third maximum, we are going to split this into 7 parts. Okay, so when you are splitting as 7, we get a divided by 7 sine theta. So bring this 7 this side, so we get a sine theta, which is equal to 7 lambda. So first we got 3 lambda by 2, 5 lambda, then 7 lambda. So it goes on. Yes, so totally we can write it as 2n plus 1 into lambda divided by 2. Okay, so this gives your general writing for the nth maximum. Okay, so a sine theta, which is equal to 2n plus 1 lambda by 2. So the central maximum is called as a 0th order maximum. Okay, so central maximum is called as what? The 0th order maximum. So this is about the diffraction in single slit. Clear? Thank you.